The concept of this video is about solving two-step equations. If you struggled with solving one-step equations and have not watched the previous video, stop and go back and watch it. This is a building opportunity here for this. But solving two-step equations usually means the two-step means there are two operations that need to be done to solve. And so this complicates things because the order does matter in which you do those. And so the order in which you would solve these equations 90% of the time, so this is not all the time, but 90% of the time is where you're going to do your addition and subtraction first, your multiplication or division next. And right now, these two don't matter. Okay, so they're not in the equation at this point. So you're either going to add or subtract first and then multiply or divide. And the only time that this stands in the way is when you've got some fractions. And that's not always true, but it is sometimes true. Remember that we're doing inverse operations when we see multiplication and division, and we're looking at the number for the addition and the subtraction to determine what to do. And last but not least, you can always check your answer for equations. The most beautiful thing about equations moving forward. So let's jump into some examples here. So the two operations that I've got is that I do have some addition and I have some division that I see, right? So I have to start kind of the farthest away from the variable. Okay, that's how I always think about it. I actually don't think about always start with addition and subtraction and then multiplication. So like if I think about isolating the x there, the x is absolutely touching the 3. But it's not touching the -7. So I'm going to start with moving the -7, which also goes to the moving of the addition or subtraction first. So remember, I am not looking at the addition sign, I'm looking at the number. And I see that it's a -7, so the opposite of -7 is a +7. So I'm going to go ahead and add a +7 to both sides. And now I have x over 3 equals, oops, I shouldn't have x'd that out over there because I have no idea what that is. There we go. X over 3 equals 6, right? So this is down to a one step. I've eliminated one of the steps here, one of the operations. So now I'm at x divided by 3. The opposite of division is multiplication. So I'm going to go ahead and multiply by 3 over 1. There's my partner of 1. So x equals 18. And if I wanted to check that, I could type this, into my calculator and see if that's true or not. It would literally say true or false. All right. This is a very standard question here with the -7x plus 9. So to solve this, again, I'm going to draw a box around the x. And the box is touching -7, so I'm not going to start with the -7. I'm going to start with the 9. So if I'm looking at the 9, it's a +9. So the opposite of +9 is -9. So now I have -7x is equal to, what is that, -35. And then when I've got -7x, that means multiplication. So I'm going to divide by -7, always the sign and the number. X equals 5. And again, if I wanted to check that, -7 times 5 plus 9, -26, and it in fact checks out. Here would be your great example of how you cannot always add or subtract first and then multiply or divide. So if you take a look at this, and we've talked about this before, never ever start something when there's a fraction involved that you can get rid of. So here I've got a fraction as my equation, a setup of a fraction. So I'm going to take care of the fraction first. I want to get to a level playing field. So you always multiply by the denominator. That wipes out that fraction. So I'm going to multiply by 4 over 1, which cancels out the fraction, leaving me with 5 plus x equals 8. And then I can look at opposite of +5 is -5, so x equals 3. If you were to move the 5 first, it's just not going to work. You want to definitely get rid of the fraction. That's just my 2 cents on the whole thing. Is if you can eliminate this entire denominator, it goes so much smoother. all right? Last but not least, this does not maybe look like a two-step equation, but it is, and it's all because of this negative. So I just want to point this out. So you're first going to start with, if I highlight the x, the number that's farthest away from there is the 23. And so 23 is positive. So I'm going to go ahead and subtract 23 from both sides, giving me negative x. Make sure you carry that down. Negative x is equal to negative 56. And then there is like a negative 1 right there. Even though you may not see it, it's there. So to separate those two, you would divide by negative 1, which that means my answer is 56. So just be careful with this one. It looks like it's a one-step, but it is absolutely a two-step equation. If you have any questions, I would highly recommend you rewatching a part of this, asking a friend, come see me, because this idea of understanding two-step equations is really important.